In this video, we'll go from zero to a clear intuition for how large language models like ChatGPT work. We'll start with machine learning, move into deep learning, and then see how predicting the next word turns into surprisingly powerful text generation. And yes, there will be quizzes in between, so keep thinking along with me. Let's first place LLMs in the bigger picture. Artificial intelligence is the broad umbrella. Inside that, machine learning is about learning patterns from data. Deep learning is a more powerful approach for messy, unstructured data like images and text. And large language models are a special kind of deep learning model built specifically for language. At its core, machine learning tries to learn a relationship between inputs and outputs. You show the model examples where both are known, and it learns a pattern. Later, when a new input comes in, it uses that learned pattern to make a prediction. Simple idea, but very powerful. The article uses a nice example with music. Suppose we have songs with features like tempo and energy, and each song is labeled as reggaeton or R&B. A machine learning model can learn a boundary that separates the two genres. Then for a new song, it predicts the genre based on which side of the boundary it falls. Now let us look at this in a simple table format. From ML to LLMs. How the idea evolves from simple prediction to language generation. Here's the main progression. Machine learning learns patterns from structured inputs. Deep learning extends that to highly complex data, such as images and text. LLMs are deep learning models specialized for language modeling. And systems like ChatGPT build on that by being trained to respond helpfully to prompts and instructions. Now in real life, things are not so neat. The relationship between input and output may be curved or highly complex, not just a straight line. We may also have tens, hundreds, or thousands of input variables and many possible output classes. As complexity grows, we need more flexible models and usually much more data too. Now that we've covered ML basics, let's test what we've learned so far. Here's quiz number 1. See if you can get it right. Question 1. What is the core goal of machine learning in this article? The correct answer is to discover patterns in data. The article frames machine learning as learning patterns that connect inputs to outputs. Question 2. In the song example, what were the input features? The correct answer is tempo and energy. The model used tempo and energy to predict the song genre. Question 3. Why do harder real-world problems need stronger models? The correct answer is because inputs and relationships are more complex. The article says complexity rises with more variables, more classes, and more non-linear relationships. Let's move from songs to images. A computer does not see a cat the way we do. It sees pixel values. Even a small image can contain over 150,000 numbers. That means the model must learn a very complicated mapping from raw pixels to labels like cat, tiger, or fox. This is much harder than the music example. Text is even trickier. Words are not numbers by default, so we convert them into numeric representations called embeddings. These embeddings try to capture meaning and usage. But language is subtle. The meaning of a sentence can depend on context, tone, and even sarcasm. So again, we need models that are much more powerful. This is where deep learning comes in. Deep learning uses neural networks, which are flexible models built to learn very complex relationships. They are especially useful for unstructured data like images and text. So if the task is too difficult for simpler machine learning methods, deep learning becomes the practical answer. Now that we've covered deep learning, let's test what we've learned so far. Here's quiz number 2. See if you can get it right. Question 1. Why are images difficult for basic machine learning models? The correct answer is they contain many pixels and complex patterns. The article highlights both the huge number of inputs and the complexity of pixel-to-label mapping. Question 2. What is used to convert words into numeric form? The correct answer is embeddings. Word embeddings are numeric representations that capture aspects of meaning and context. Question 3. LLMs are best described as what? The correct answer is a text-focused deep learning model. The article positions LLMs inside deep learning with a focus on language. Now we reach the key idea. A language model is trained to predict the next word in a sequence. If the input is, "the cat likes to sleep in the model assigns probabilities to many possible next words. In that sense, this is again a classification problem, just with a very large vocabulary of possible outputs. Why are LLMs so capable? One big reason is training data at massive scale. From ordinary text, we can create huge numbers of training examples by asking the model to predict the next word again and again. Over time, the model becomes very good at recognizing patterns in language, syntax, facts, style, and common sequences. Once trained, the same next word mechanism can generate full text. The model predicts one word, then uses that word as part of the context for the next prediction, and so on. That is how paragraph generation works. So the magic is not a separate trick. It is repeated, next word prediction happening very effectively. GPT stands for Generative Pre-trained Transformer. Generative means it can produce text. Pre-trained means it has already learned from massive amounts of text before you ever use it. Transformer refers to the neural network architecture behind the model. Even without going deep into architecture, this name tells us a lot about how the system works. Pre-training gives the model broad language ability, but that alone does not make it reliably helpful. That is why later stages matter. Instruction fine-tuning teaches the model to follow prompts better. Reinforcement learning from human feedback helps align outputs more closely with what people find useful, safe, and relevant. This is a big reason chat systems feel more conversational and practical. Now that we've covered LLM workflow, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. What is the main training objective of a language model? The correct answer is predict the next word. The article presents next word prediction as the central idea behind language modeling. Question 2. How does an LLM generate longer text? The correct answer is by predicting one word at a time. Each predicted word extends the context for the next prediction. Question 3. What does the pre-trained part of GPT mean? The correct answer is it learned from large amounts of text beforehand. Pre-training happens before the model is adapted to instruction following or chat use. Question 4. Why are instruction fine-tuning and human feedback important? The correct answer is they help the model align with user needs. These stages make the model more likely to respond in useful human-preferred ways. If this made LLMs feel less mysterious, mission accomplished. The key takeaway is simple. Behind the impressive responses is a model that has learned language patterns at huge scale and uses them step by step to predict what comes next. Keep exploring, keep questioning, and I'll see you in the next one.